Welcome back. This is lecture part 3 for module 4. I hope you enjoyed your short break, and let's get into this final part of this module. Chapter 6 discusses formal verification strategies. It's important to define your security and your security goals before building a system to make sure it fits the organization's goals. It's not simply sufficient to take a security program that's offered by a vendor without change, or that you get out of a book or out of a lecture. Every security system needs to be designed with the goals of the organization and the members of the organization and the uses of data in mind. You need to make sure that everyone who's working the organization, the IT department, and the users are in agreement, that they share the same goals and rules and understand the rules, and the rules are not unnecessarily complicated. The book discusses the use of mathematical equations to express rules. The nice thing about mathematical equations is you can write them in a way that there's no ambiguity, but at the same time, people aren't used to using mathematical equations, or algebraic expressions might find them impossible to understand, and they could give up. If you make things too difficult, people tend to give up on them. The mathematical formulation of rules needs to keep usefulness in mind, and if it's too complex, it'll be ignored. In addition, mathematical models do not conform to real-world scenarios. It's easy to take a simplified worldview and state it as a simple equation, but you're likely to have, on a daily basis, a number of scenarios that arise that aren't included in the model. If you tried to create a model for every human variation, it would be too complex and doomed to fail unless we perfect artificial intelligence someday, and even then it might not be a useful system. Data and system obsolescence also require constant upgrading the model. You might end up spending most of your time writing and rewriting mathematical models and not actually operating a security system that works for the company and the users. Integrity models are systems that are used to check data, database, and communication integrity to make sure that data has not been corrupted. These models check for corruption during data transmission. It's very common that data communications are interrupted and need to be constantly corrected. And also it can check to see whether or not data within files or on databases or servers have been corrupted. One method that's commonly used, one integrity model that's commonly used, is what they call the Chinese wall model. That term has actually been kind of eclipsed in use, is now referred to more as confidentiality walls. These include or exclude users based upon a need to know that helps block cross-contamination of confidential information from multiple sources. Let's say you've got two teams in your company. Each are working on different projects with third parties, but those two third parties are competitors. They're not going to want their competitive information to come through your company and be inadvertently disclosed to the other competitor. So it'd be important to have a confidentiality wall and say that Team 1 and Team 2 can't share the same data set files in order to protect the confidentiality of both the third parties. Discretionary models are ones that user discretion is used to establish the model. With any of these can suffer from over or under inclusion of persons or data sets and can be too complicated to enforce. And if the discretionary model is being built by someone who doesn't understand the organization or the needs of the users, they can build a model that's completely useless to everyone. Additional integrity models are discussed in Chapter 14. I'll review these for you since it wasn't a formal part of the reading. I do think it's a short chapter. It'd be very useful for you to read those because it really fleshes out what we're talking about in Chapter 6. But in Chapter 14, the basic concepts are that changes in data should be reviewed to determine whether data was corrupted in use or transmission or by an attacker. There's a number of strategies for doing that. Hamming codes are good examples of error detection and correction mechanism that's been mathematically maximized to be the most efficient and to cure multiple kinds of data corruption. Digital signatures can be used to make sure that only authorized individuals access or sign documents. A current example of a digital signature program used by law firms is DocuSign, where the third-party entity DocuSign authenticates the identity of all the signers, and then the signatures have to be entered into a document that can't be changed except for initialing, and then DocuSign wraps up the final document signed by all parties of package and publishes that back to the parties. It's a very good system for ensuring that only authorized users can access and sign documents. Integrity checks also include the creation of diff files to review changes made. These are similar to redlining. A diff file report will give you a printout of all the changes that were made between the original and the later file, and you can scan those to see if the changes were authorized, inadvertent, or if an attacker had tried to introduce something new to the file. The final integrity model that Chapter 14 discusses is GPS mapping. GPS is now used fairly extensively in all cell phones, computers, and a lot of other devices. And in checking where the GPS location is of a device when it accesses the network can be useful to determine whether the device has been taken to unauthorized areas, if an unauthorized user is trying to enter the system. There are a number of software programs now that will check the GPS data and alert the IT department whether something appears to be off-net or in an unusual location. In conclusion, policies should be designed with the network security needs and personnel in mind. Complicated policies will be bypassed or ignored. Some systems can be used by hackers to compromise or defeat systems if not managed, and sometimes these are the most dangerous attacks because the system that you're using for security has been compromised in a way that actually lets an attacker in unseen. Policies, programs, and manuals that are entertaining or interesting are more likely to be followed. My experience with compliance manuals has been I can write a 50-page compliance manual and give it to a department head, and that 50-page manual will sit on this shelf unread forever. What's much more useful are very brief flow charts or checklists or entertaining, as entertaining as you can make this, periodic meetings with real-world examples of what people need to look out for. They're much more likely to follow those programs and understand them. And finally, systems that are built into the software which execute automatically without user interface and send notices such as log files to track non-compliance are very efficient. I've worked on a number of systems where you needed people in the field to undertake certain steps, and if they have to fill out a report in the field and the report has got categories they have to check off, you can have someone review those to determine whether or not there's been a problem. And the more automated the system is, the more likely you are to find kind of inadvertent errors in the field. Thank you very much for attending Module 4. And next week, one of my partners will be presenting Module 5. Thank you very much.